Hello, my name is Oleksandr. For your attention, a report of the topic approximation mathematical model of an absorption heat pump with steam heating for integration in the steam turbine thermal scheme is of rate. Currently, much attention is paid to energy saving through the introduction of energy efficient technical solutions in the heat and electricity production. One of a solution to improve the efficiency of heat and electricity production at cogeneration heat power plants is the implementation of heat pump for deepening utilization of the burned fuel heat. To solve the problem at the first stage, it's necessary to improve the mathematical model for calculating thermal processes in power plants. In this regard, the main task of this stage follows. The aim to develop a finally simple approximation mathematical model of steam heated AHP based on the characteristics of manufacturers of real thermal transformators and applicable in solving problems of its integration. To investigate the level of changes in the material flows of the powerful steam turbine with an integration absorption heat pump with steam heating during the heating season. And tasks are presented also in this slide. For further modeling of AHP, the technical characteristics of powerful AHP of Broad Corporation were analyzed. In this case, consider the standard characteristics of AHP in terms of standard pressure losses in heat carriers, flow rate of heat carriers, and electric energy. Interpolation dependence is also presented for determining the relative thermal power of AHP, which depends on the temperature of the chilled water after the pump, the temperature of water that is heated, inlet and outlet. The dependencies on the nomogram are linear. To approximate each of the four straight lines on the right side of the nomogram and 5 on the left, it is enough to specify the coordinates of 2 points based on these conditions. The base point were interpolated using a one-dimension spline. The calculation is carried out using a set software package developed by the Anatoly Pedgora Institute of Mechanical Engineering Problems, NASA of Ukraine. It is based on a set of balance equations when constructing a heat scheme in the form of components and connections between them. This software package has been improved by adding algorithm for determining AHP indicators using approximation dependencies, factory characteristics, and consideration equations. Accordingly, this component of the software package is characterized by the presence of initial date and determined characteristics. This algorithm served as the basis for creating software models for determining the characteristics of AHP and its subsequent integration into the turbogeneration thermal scheme. The scale and importance of solving the problem of integrating AHP into the thermal schemes of powerful cogeneration plants is evidence by the general characteristics of the existing cogeneration heat power plants on the territory of Ukraine. The analysis carried out shows that turbines of PT60 type are mostly widely used. Also, for comparison and further computational studies, the outdoor temperature are given according to this tool for the region where PD60 turbine plants are located. The scheme of AHP integration into PD60 thermal scheme, the future of which is the presence of only one extraction for steam supply for heating, is shown in this figure. As can be seen from this scheme, the steam of the heating AHP is taken from the regulated production extraction PD60, operating at a pressure 1.3 megapascal. The pump is heated by steam with a pressure of 0.474 megapascal coming from the exhaust of an additional steam turbine with a back pressure. It was installed for the purpose of energy saving. The features of the mathematical model of PT60 thermal scheme associated with the desire of bring the result of calculation closer to the real ones include the use of the factory approximation dependence power of lower pressure path from the flow rate of low pressure path. The processes of steam expansion in the flow path of PD60 turbine in the ES diagram with the RCD closed is shown the solid line on figure. When AHP is integrated, in many cases of pressure in condenser, the steam flow to the condenser increases and heat drop is used in the low pressure part. Characteristics of PT60 thermal scheme at average monthly loading modes with integrated AHP 24 megapascal while providing heat supply and supply for production extraction 80 tons per hour of steam. Power of a small steam turbine with a back pressure more than 1 megawatt. The results are presented for each month in the heating season on these slides. This slide and this slide. Calculation of the change in the performance of PT60 turbine unit after the integration AHP into the thermal scheme is presented in this table. To determine the change in the amount of harmful emissions of CO2 and NOx into the atmosphere, we used experience. When burning 1 ton of natural gas, the following amount of harmful emission is formed: CO2 equal to 0.726 tons per ton and NOx equal 0.0143 tons per ton. The data in this table are shown. When AHP is integrated, the consumption of fuel and the technical water for feeding of the circulation system has a steady downward trend. The difference in the volumes of electric power generation with integrating AHP into PT60 from the non-integrated depends on the operating mode. PT60 modes without a heat pump, where big hot water boiler works, allows in integration. The conclusions are presented on this slide, but in the end, I would like to note that the realization of absorption heat pump at powerful cogeneration heat power plant will save fuel resources and reduce the harmful impact in the environment during the heat and electricity generation. Thank you for your attention.